Yes, class. Am I audible to all of you? Aksa, Alan, Farhat,
Yes, ma'am.
and who else? Hanifa, Memuna, and Saifullah. All right. So you already had completed vectors. Yes. So vectors are over. Now we'll start with, at least we'll try to complete motion in a straight line today. So in motion in a straight line, you have to have knowledge of few terms like distance, displacement, velocity, average velocity, when to calculate instantaneous velocity. Same goes for acceleration, average acceleration, instantaneous acceleration. At some places you have to perform differentiation, some places you just have to apply the formula, right? So these basic things you should be aware of. So from this, I'll just keep on telling you what all things are important and from which things, what type of questions can be asked, what type of questions can be modified. So from frame of reference, everyone knows that is the place of observation from which you are observing. For example, for a person who is standing on the ground, it may appear that a person who is sitting in this train, moving train, is also in motion, but the same person or for the same person, passenger in opposite side in the train, within the train, the person will appear at rest. So it's whether the person which we are considering is in motion or at rest. Both the answers are right. It just depends upon the place of observation. You cannot distinguish and just designate as in motion or at rest. So when do we say a body is at rest? Rest means there is no change in position. All right. When we say a body has not even commenced the motion. That we say it is at a state of rest. And in motion, when the position is changing, that is the state of motion. Now, motion in 1D means you have to have knowledge about distance and displacement. So see, distance is what? Distance is the entire total path that is covered. If a person goes from A to B to C to D, the entire path, 5 plus 3 plus 5, all the entire path, that will be distance. But when we just join the initial and final position, that is get the shortest distance that is possible for the point to be reached, that is known as displacement. And other difference is that distance is a scalar quantity, whereas displacement becomes a vector quantity. Displacement can be negative, it can be zero, it can be positive, while distance can only be zero and positive. You cannot have a distance negative. Someone has traveled minus 18 kilometers. No. If a person has traveled minus 18 kilometers, that means this is displacement. Why do we have negative sign in displacements? Because these are vector quantities, and in vector quantities you have directions, and because of directions we can write it as positive and negative. So for distance, directly keep on adding it the way it is given. And for same thing for displacement, just use and consider the shortest path that is possible. Questions, statement-based questions in NEET can be asked on displacement and distance. Statement-based question as in which questions, suppose it says that can displacement and distance be equal? Can displacement be greater than distance? Can distance be negative? Such that statements will be given. And now you have seen statement-based questions have increased, especially in the last year's question paper, if you check. So statements will be given to you. It can be asked which of the following statement is correct. So you have to pick up the statement, or which of the following statements are correct. So there will be plenty of, let's say, A, B, C, D, E, F, G, H. These many statements are given. And in the options, you'll be having only A, B, C is correct. Only A is correct. Both B and C are correct. Like this, you'll be having the question. So that's why a little basic about the theory part is important, because kinematics is your basics. Fine. These are very basics of your syllabus. Distance, displacement. Now, from speed, velocity, all this term, what you have to remember from speed and velocity, you should remember what is the definition basic. So when the distance is getting changed with respect to time, we say this is speed, right? Whatever entire distance, calculate the entire distance divided by the entire time. That will be speed. But when I say calculate the entire displacement and then divided by time, that becomes your velocity. So same thing, you have distance, you have displacement, Similarly, their rate of change with respect to time, that will give you speed and that will give you velocity, right? So rate of change of distance, this will be speed. But how to apply it? And yes, class, this conversion 1 kilometer per hour is equal to 5/18 meter per second. If your answer is, and the options are not given in kilometer per hour, quickly multiply the term by 5/18 and get your final answer, because all the units have to be done together. Yes. So types of speed, under the type of speed, you have uniform, non-uniform. In non-uniform also you have average and instantaneous. So I'll tell you how to deal with average instantaneous, and that will be similar for acceleration. So there won't be much repetitions in acceleration. See, for uniform speed means the speed is not changing with respect to time, with respect to position. If you say speed is not changing, that is what is meant by uniform speed. So for uniform speed, you can say constant term also, you can use constant term. In this initial instance, it is 5 meters covered in 2 seconds. Then in the next instant, this is again 5 meter per 2 seconds. So when you take the speed 5/2, 5/2, 5/2, all become same. So that means it is covering exactly equal distance in equal interval of time. Same distance is covered in same intervals of time. Neither time is changing nor distance. That means that your speed is constant and uniform. But when we talk about now non-uniform speed, see, you have two cases, two methods how to solve question. You have to first go by time. Look at the time, check time. If you see time is given, the time is given in duration from this to this, a particular initiation of time is given and a final ending is given from 4 p.m. to 7 p.m. from 0.3 seconds to 0.9 seconds. You have a particular fixed duration of it. So if you have a particular duration, you will use the formula. But if you get a very, very particular instant of time where you have to write, that time you will be using differentiation. You will directly differentiate it. Differentiate it and then put the value of whatever instant is given. Fine. So in this way, you have to find out for non-uniform speed. Like here also, if you see these are changing. Distance is changing. Time is also changing. Either can change, both can change. This is how you have to identify. So formula is this. Yes, total distance by total time. When I say average value will be initial of the total time. These questions we'll do it. These types of questions have come a lot. We'll do it this. See, whatever is the difference in the distance, initial distance minus the final distance, divided by the initial time minus final time, right? Initial time difference, my initial distance separation or displacement difference divided by initial and the final time difference. Once you have these differences with you, divide it, that will give you average velocity. And when you differentiate these, when you differentiate it with respect to time, you get instantaneous. Fine, these questions are also there. These are very basics. All right, these questions, there are plenty of questions are there. Same goes for velocity also. It's just that you have displacement over here. And same thing is valid for acceleration as well. Same thing. It's just that in acceleration, you have velocity change. In velocity, you had distance and displacement changing. In acceleration, you have velocity changing. So whatever is the change in velocity with respect to time interval, that will become your acceleration. Now, same thing, you have uniform, you have non-uniform. When and in your non-uniform, you have both the cases. Again, average and instantaneous. So for average or instantaneous, same thing. You see a duration, use average. You see an exact value, 0.00056 seconds. So directly differentiated. This is what you have to remember about acceleration. So basics were your distance and displacement, and they are very basics for your upcoming lessons as well. Distance and displacement and basics of kinematics that will be used ahead as well. So basically distance, displacement, distance in scalar form, displacement in vector form, right? Then velocities will come. Rate of change of distance will become speed. Rate of change of velocity will become, a rate of change of displacement will become velocity. Like this you have it. Then you have uniform, you have non-uniform. In non-uniform you have average, instantaneous, depending upon the time duration. If time duration is given, or if time instant, one particular instant value is given. Same thing when you talk about rate of change of speed, rate of change of velocity, both the things, you get acceleration. Now in acceleration also you have uniform, non-uniform. In non-uniform also you have average and instantaneous. That's it. So all the questions will be using these concepts only, basic formula only. You will have to divide every concept. As in a question is given, divide whatever, break it into compartments, and then solve each of it and ultimately add it. That's how you can solve questions in 1D especially. Otherwise, it will become very difficult for you if you sum up everything. Then uniform motion. These equations are very necessary for you to remember. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. All these three equations along with this equation as well. Questions are asked from this equation as well. Sn is equal to u plus a by 2, 2n minus 1. Fine. So this is the final displacement equation. If for nth second, some random nth second, fifth second, if I asked you, not 5 seconds. When I say 5 seconds, what is the difference between this equation and the other three? When I say no 5 seconds, calculate the time at 5 seconds. That means from the very beginning, calculate the time when the time has elapsed to be 5 seconds, right? But when I say nth equation, fifth, right? Nth, when this term comes, fifth. So for fifth, what does it mean? From 0 to 5th? No. From starting, if it is, that means complete duration. It means from the 4th to the 5th second. Right? From the 4th to the 5th second, that is the nth second. And for nth second, we obviously cannot use the other equations because they have the time period, time duration from the starting, from 0. So for nth, we have specific equation. Sn, that is displacement, this is not distance, is equal to u plus a by 2, 2n minus 1. Now, n can be your nth time, whatever is mentioned to you, right? Whatever it is given, you can put it here. So I hope the variables you are aware of. V is final velocity, u is initial, a is acceleration, t is time, s is displacement. This all of you can manage. Mainly through the questions we'll try to see. Yes, motion under gravity, acceleration due to gravity's value, take it as 9.8 unless specified. Otherwise, it will specify to you to use 10. All right. And rest of the questions that will come from your this portion as theory part, that will be related to your gravitation lesson. So gravitation also you will do. So under gravitation, study these lessons. What about the acceleration due to gravity? Its dependency on other quantities, like this. So in this also, sign convention is very important, class, because you don't have anything new in this. Motion under gravity, this is not one specific formula that I'll tell you. This is the formula. Remember, questions, motion under gravity will be solved now. Here we'll be seeing it through the question only. See, remember, always gravitational force is acting downwards. So acceleration due to gravity will always act downwards. That is fixed. Now it depends on you whether you write it as positive, you write it as negative. Take one direction as positive, take the other as negative, and whichever quantities are falling, according to it, substitute their respective signs. Fine. Sign convention is very, very important, not only under motion under gravity, for motion in a straight line as well. For left, right, and for right side, you can take one as positive, one as negative in this manner. You have to write it. Sign conventions are very, very important for your kinematics equation, for your mechanics. Fine. So these certain questions, these are relative velocity is very easy in motion in a straight line. Just take the difference. You just have to take the difference. But the problem is that students forget to put the sign. If both are in same direction, both will have the same sign. So it's better to take positive, right? If one is going in one direction, other is going in another direction, then you'll put the direction. Sign. Yes, your sign conventions can be any. That is not fixed. C class, again, I'm repeating this fact. Sign conventions, these are independent values. Even in the options, you will not get the same option with the both the sign conventions. Sign convention is a completely independent thing. You have to fix your sign convention. For example, let's say I have taken for a specific question, I have taken left as positive. So if VA is falling towards left, I'll write it as negative. If it is towards right, I'll put it as positive, right? So right, left, their signs, up, down, their signs, you have to choose by yourself. Whatever is supposed for me, I have chosen left side as negative. You have chosen left side as positive. So it can happen that my answer will be minus 10 meter per second and your answer is plus 10 meter per second. But ultimately, it's just plus minus is just defining the direction. That's why we are saying, no, these are vector quantities which have the direction and magnitude. Fine, this part is clear? Okay. Yes, this was your doubt. No, right. So yes, sign convention class, it can be in, it has to be your sign convention. But just remember, for acceleration due to gravity, don't put the direction reverse. Direction is always fixed, that is downwards. Now you can put downwards and upwards up depending on your direction. These graphs, these are very basic graphs. These graphs you all know. Some through the questions only, it is better to perform the rest of the revision part. So I'll write down the question. 2 to 3 minutes you will take to solve it yourself first. Whichever is the correct appropriate answer you're getting it, send it to. All right. Note down the question. Try it yourself and just write ABCD. No need to write rest of the details of it. Yes, most of you have given the correct option. See, for average velocity, you have to write out the total distance. Let's say total distance, this is 2x. Total distance, this is 2x. If each part is x with velocity v1, second part has velocity v2. But total distance is 2x. So what will be average speed? Average speed is total distance. Always remember, this is total distance by total time. So here I do not have time, but I know velocity is equal to distance by time. So what can I write for time? Time 1, t1, this will be x1 by v. Similarly, t2 will be x2 by v, right? v1 and v2. And since we know x are equal, so what we can do? Total distance is 2x. And first time will be x by v1 plus x by v2. That is the average velocity. This is the average velocity that we are getting. So this, if you simplify, this whole term will go 1 by v1 plus 1 by v2, and this v will come down 2 by v. So option B. Note it down. Some other questions I'm writing. Yes, right. So Farhat, Saifullah, correct. See, you just have to differentiate. Here, velocity is given, distance is asked. So what we are going to do? Velocity is given, the distance is asked. So right now, dx dv is equal to dx over dt. But this time dx is asked. So you will integrate dv dt, right? V dt simply, not dv dt, v dt. So dx, when you'll integrate, this will become at plus bt square dt. You're integrating it from 1 to 2. So a is constant. This will become t square by 2 from 1 to 2, plus again b is constant. This will become t cube by 3 from 1 to 2. So this becomes a by 2 t to the power 4. Instead of writing that separately, I'll write it in one step only. I hope that you will understand. This much integration you all know. So 2 square minus 1 square plus b by 3, again 2 cube minus 1 cube. So this is 4 minus 1, that is 3a by 2, plus that is 8 minus 1, 7b by 3. So B option. Yes, sir. Right. Others also, last 1 minute, then I'll discuss. See class, here velocity is beta x to the power minus 2n. Now acceleration is what? Acceleration is differentiation of it, rate of change of it, right? But if you differentiate it here, will you get any answer? This is this with respect to time, right?
No.
No, this is. So what we have to do, what we can, if we divide and multiply it by dx, so what will happen? They'll cancel, that will be 1. So it means we can divide and multiply by the same numerator. See class, this quantity you all are aware of, dx over dt. What is this quantity? Dx over dt, which quantity is this?
Velocity.
Velocity, right? So this is velocity. So it means acceleration can be written as v dv over dx. So acceleration, velocity is what? Velocity, this is beta x to the power minus 2n. And one place you have to differentiate x to the power minus 2n over dx. Now you can differentiate it. Here you are differentiating it with x. Here if I write t, then this would be invalid. That's why we have performed this step so as to reach it here. Now simple derivation you have to perform. Beta x to the power minus 2n. Beta is a constant. Beta will come here, minus 2n x to the power minus 2n minus 1. X to the power n is there. How do we write? Nx. So if x to the power minus 2n is there, won't we write it as minus 2nx? Same thing. And what happens to the power? N minus 1. So here also 2n. So 2n minus 1. Same thing. Now you just have to club this up together. Minus 2n. Then beta into beta will become beta square. X minus x will be common. Minus 2n will become minus 4n with this minus 1. Basically, it's like minus 2n minus 2n minus 1. So how do we write it? Minus 4n minus 1. The values also, if it gives you, it can give you in the term in form of values. So if values are given, put it directly. And in such type of questions, usually modifications are not given. This was a question from your AIPMT paper. But let's do one more question at least on this differentiation integration part so that this basic is clear. Yes, others also answer. Only Saifullah has answered. Yes, others also. Whatever answer you're getting, let me know. Take 2 more minutes and I'll discuss this. Yes, Farhat and Alan have also answered correctly along with Safila. So 3 students could answer this. This was a very easy question, class. This was from your, I think, 2007-6 AIPMT question. Look here, you just have to, want to find out velocity. So velocity will be differentiation. See, 9 t to the power 2. So 2 into 9 will become 18. T to the power 2 minus 1, that is t, minus 3t square. This is velocity. Whoever is having an issue in this step, you are having problems in your calculus, differentiation and integration. Revise that, get it stronger. And acceleration also, if we want to find out acceleration, you can differentiate this. That will be 18 minus 60. That's it. See, for when the acceleration is 0, maximum speed it is saying, no. Maximum speed means acceleration 0. So 18 is equal to 60. That means time is 3 seconds. This was only missing, no rest of things we had. Now you have time with you. So once time is there, you can substitute it. X is equal to 9. T square was there. So 3 square minus 3 square. 3 square t cube was there. So t cube and 3 square. So that will become 9 into 9 minus 27, which is 81 minus 27, 54 meters. That's it. You just had to find out this. This was very easy part. Note it down, those who haven't. Hanifa, just look at your calculations again. Just see which option. So Alan and Farhat's answer are only correct. Let me tell you, see class, where are you all committing errors? Just remember, S is equal to UT plus half AT square, right? You all know this equation. It says from rest, this term becomes 0 because U is 0. So S is only half AT square. So see, S1 is half A 10 square. S2 is half A, how much was 20? 20 square. So S1 by S2 is 10 square by 20 square. So S2 is equal to 4 times S. C option. Please note it down, those who haven't. So only Hanifa has answered correctly here. Look, class, all of you are giving varied answers. Here you will use, this is third second, not 3 seconds. Third second is asked. It means nth equation, Sn is equal to u plus a by 2 to n minus 1. Starting from rest, u becomes 0. So S3 will be, A acceleration is 4 by 3 into 2. 2. N is 3 minus 1. So 2 into 3, 6, minus 1, 5. 5 into 4, 3 into 2. You have 10 by 3 meters. So C option is right.
Ma'am, what is after particle in?
This particle in around the point. Yes, Saif and Farad. B option. That is C. C. Why is C we are going to choose? Maximum velocity means the point at which dx over dt. This is maximum, right? That is what is meant by it, velocity, because this is velocity. So maximum slope, when are you getting? This, or this? This is becoming again static. So this is maximum slope, you're getting it here only. So you will see it through the maximum slope. Yes, so till now only Aksa has given the correct answer. Look here, class. Initial velocity of the stone, we are taking it as 0 because this is given, this is released with 0 velocity. So initial velocity of stone, this is u is 0. Time to reach the ground, this is 4 seconds. So let's say, let's take this as positive, downwards as positive. So 10 meter per second square. So for height of tower, I'll use the formula h is equal to ut plus half g t square. So 0 into 4 plus half 10 into 4 square. So this will become 80 meters. So that is option C. Note it down quickly and text me done once you have written it. All right, all right. Those who have completed, you can leave. Now tomorrow we'll complete motion in 2D, projectile motion. So whatever doubts you have, you can let me know. All right, class.